Hello, welcome back to our Protecting Our Planet Day, live from Southampton from the National Oceanography
Centre.
Oceanography, why do I keep saying oceanographic? Oceanography, it's even written in front of me in big letters, and I keep getting it wrong. Thank you very, very much for joining us. I know thousands and thousands of people are logging on to join us, and I hope you've enjoyed our session on ice. That sounded a bit like dancing on ice.
There's no dancing.
Nothing like that. Today we are going to be exploring how we understand the health of the planet, talking to scientists, talking to experts, understanding how climate change is affecting our planet and what we can do about it. We've looked at ice so far. Thank you very, very much for your questions, by the way. We've been getting your questions coming in, and we're going to spend a little bit of time, hopefully, answering some of those questions a little bit later on in the day. But we are going to move on to our next ecosystem.
Yes, we are going to look at oceans.
Yes.
We're going to start off with Professor Angela Hatton. She's the Director of Science and Technology here at the National Oceanography Centre, and she's given us a quick introduction to what they do here.
Hi, my name is Angela Hatton, and I'm Director of Science and Technology at the National Oceanography Centre. And I'm joining you today from the Command Centre for Boaty McBoatface. I wanted to tell you about why I find the ocean so fascinating and why at NOC we care about ocean science. Although people talk about different oceans, there actually is only one ocean. It's a vast, interconnected system divided into large basins and seas. And in the ocean, everything is connected. The ocean is vital to the functioning of our planet. It regulates climate, and in recent times has helped us with man-made climate change by taking up about 30% of carbon dioxide and about 93% of the excess solar heat we have generated. And this heat and carbon is redistributed through the ocean, along with essential nutrients. The ocean covers 70% of the Earth's surface, with an average depth of 4 kilometres, 11 kilometres at the deepest. It represents 96% of the habitable space on the planet for living organisms. At NOC, our research allows us to understand this and the biology in the oceans, whether at the surface or in those deepest parts. And we discover interesting and occasionally really weird new species every year. But it's not just the new species we work on, it's the interesting habitats they live in, such as huge sea mountains and mountain ridges, seafloor canyons that put the Grand Canyon to shame, hydrothermal vents, or the giant abyssal plains. On land, biology is thought to live within the top or just above the top 12 inches of the surface. But in the ocean, it lives throughout the entire water column, even down to 11 kilometres down, where some of the most extreme environments on Earth exist. And it's been said that in terms of biomass, plants are mostly terrestrial, whereas animals are mostly marine. One of the reasons for this is on land, plants have lots of structures, but in the oceans, plants are microscopic, so small they can't even be seen with the naked eye. And these plants, which we call phytoplankton, can only live in the sunlit surface of the oceans. Below this, it is cold and dark and the pressure is extreme, but it's still teeming with life. Those microscopic plants cover 70% of the Earth's surface, and that means that the oceans generate about 50% of the oxygen we breathe. And those plants are the base of a food chain for a whole range of tiny zooplankton who move up and down the water column. And this, along with debris falling out into the deeper ocean, transports carbon deep into the interior of the ocean, supplying food to the rest of the animals living in deeper waters, but also helping to keep carbon dioxide from returning to the atmosphere. And so the ocean is home to huge biodiversity, supported by a very small number of microscopic plants in the surface. It's estimated that around 2.2 million marine species live in the ocean. However, we know so little about the ocean in the deep. We believe only 10% of them have been fully described, and we're still discovering more. NOC hosts the Discovery Collection, a unique collection of deep-sea animals. This collection provides vital insights into species that live in the extreme ocean depths. But this is not used just by NOC researchers. It's a source for the whole marine science community. and it allows us to show people some of the mysterious and incredible creatures that live in the ocean. As well as enhancing fundamental understanding of the oceans and discovering new things, NOC Science aims to understand how the oceans are changing and the consequences for people who rely or live near the ocean. The ocean provides important resources. For instance, the ocean provides the primary protein source for well over 1 billion people on the planet, and this may be changing. We know that people depend on the oceans for food, transport, energy, livelihoods. However, it's been estimated that 80% of that direct benefit or economic benefit comes from the ocean being healthy. We depend on maintaining healthy marine ecosystems in order to actually have that benefit. And that's increasingly under threat. I mentioned earlier that the oceans have taken up heat and carbon as a result of human activity. But this is changing the ocean physically and chemically, with serious implications for the biology we depend on. Human activities affect marine life and marine habitats through overfishing, habitat loss, pollution, ocean acidification, and ocean warming. As an example, coral reefs, which occupy 1% of the ocean, are home to 25% of biodiversity and are nursery grounds for a whole range of other species. Ocean warming and changing pH are leading to an increasing number of bleaching events. And if you add the effect of sea level change and pollution onto fixed organisms living in the ocean, that's having a significant impact. So in an era of climate change, expanding global population, and intense resource exploitation, it's essential that we work globally and collectively to investigate the processes of change and the variability affecting our ocean, and to coordinate large-scale observations, data sharing, and prediction systems that we can use for everyone. Working with the oceans will require a strong sense of balance. If we are to use the ocean's wide-ranging resources, but maintain the health of the ocean for future generations. NOC scientists have worked with communities across the globe to support the sustainable management of coastal resources, including seagrass beds, coral reefs, and fisheries in coastal communities. And we provide essential data and information so policymakers and international bodies can make sound evidence-based decisions. At NOC, our purpose is to make sense of changing seas, but we also ensure that we maintain this balance for a sustainable ocean into the future.
Thank you very much, Angela. Fascinating talk. We're going to have an in-depth question and answer session a little bit later on. I know you've been sending some of your questions in already. We've got lots of those, and hopefully we'll have time. Well, not hopefully, we will have time to answer some of those.
So please send us your questions for Angela, and we'll put them to her in just a few minutes. But before we do that, I had a chance to catch up with Captain Stuart McKay of the RRS Discovery. So let's have a listen to what he had to say. Hi, Stuart from the RSS Discovery. Are you there?
Hello.
What is your scientific goal? What are you going to be doing on this expedition?
So we're working on a project with CFAS, and it's the Blue Belt project. So we are essentially looking at ways of managing the marine protected areas which are around the overseas territories. In this particular case, around Ascension Island and St. Helena. So that's ultimately where the ship will be getting, going down towards, working around these islands to try and learn more about the oceans and the sort of ecosystems that are around these islands, in order that we can protect them in a more efficient and manageable way.
So I know we do a lot of work on looking at the oceans and managing the oceans using remote sensing observations, so using satellites and other instrumentation to look down at the oceans. What advantage do you have as a vessel actually in the oceans? What measurements can you make that we can't make any other way?
We've got got a very capable sort of hydroacoustic suite capabilities there, so we can map the seabed really in fine detail. We can find fish. We can use our sub-bottom profilers, which would give us a map, an image of what's beneath the surface, what's beneath the ocean floor, so we can have a look there. Really, the ship itself, it's very adaptable and flexible, that we can provide seismic research, we can work with ROVs, we could work with autonomous vehicles, we can take seawater samples. So we're really flexible, really capable for a variety of different oceanographic requirements.
Fantastic. So you're the captain of this research vessel. Tell us a bit about what your main jobs are and how you got to have this role.
I suppose my main job is to make sure that things run smoothly. So a lot of that involves making sure the right people have the right information at the right time. It's my responsibility to make sure that anything we do on the ship is both compliant with legal requirements and is safe, that we are operating in a safe environment. That's for the people on board, for the ship itself, and that we are protecting the marine environment. And that's encompassed with various company and legislative requirements. But being an oceanographic vessel, it's at the forefront of everything that we do to protect the marine environment. Safety, protecting the marine environment, and making sure the ship runs smoothly are my sort of main roles, I suppose.
Okay, and how did you get to have this role? Did you know you wanted to do this since you were a kid? Did you sort of develop an interest in the oceans or in marine life as you went through your career?
So my dad was at sea, so I grew up knowing about the sea and what was required for somebody to work at sea. I sort of got there in a roundabout way. I went to university and was working in Edinburgh, and then I decided to go to sea myself. So cadetship, worked on a variety of different types of ships, studied through college, passed my exams, officer of the watch ticket, then back to sea, did my chief mates, and ended up working on these scientific research ships, and worked my way up from there.
So tell me a little bit about how long you've been a captain for, and maybe you can think of kind of a highlight of your career so far.
So I've been a captain for just coming up 4 years, and highlights that I can think of are South Georgia, which is an island in the Southern Ocean. It's there's a British Antarctic Survey based there. Not many other people. It's all wildlife, glaciers, icebergs, and I remember my first experience of it was sailing up the east coast in thick fog, and we were turning in towards the island. We were going to test and calibrate some equipment in one of the bays, and just as we got through the fog, and the island just it appeared in all its splendour, and it was quite a magical moment. I'll never forget that. So that one sticks with me. And also the time we sailed into a volcanic crater in the South Sandwich Island as well. So I took the ship in. We sailed through an opening. It's an ancient sort of volcano. It wasn't active anymore, but the shape was still there. It was still this caldera, and we spent an hour or so in there, sort of looking about, inside this old volcanic crater, which was pretty cool. And then off we sailed again and carried on the science. So things like that you don't normally do on a bulk carrier or a ferry or an oil tanker. So that makes this job a little bit more interesting.
You truly get to go to places that most of us only dream of getting to go to. So that's fantastic. And so just to wrap up, is there any advice that you would give to your younger self? If you were talking to yourself as a teenager, what would you say to yourself with all the knowledge and experience that you have today?
I would say if you're interested in something, then just go for it. Don't hold back. Just you know, if don't be afraid to try and do something that you're interested in or you feel passionate about. Yeah, just trust your instincts and try and have a bit of fun along the way.
Fantastic. Thank you so much, Stuart, for joining me today. It's been a real pleasure talking to you.
That is the best bit of careers advice ever.
Yeah, do what you want to do.
Don't be afraid. Don't wait for permission to do what it is that you love doing. I think that's really good.
Yeah, fantastic.
Have no fear. There you go.
Yes, and actually, talking about no fear, I also had a word with the captain of the RRS, James Cook. His name is also James, incidentally, and he had some other insights to share with us. James, great to see you today. Tell me a little bit about your ship. Where is it today, and what are you up to?
So we're currently about 400 miles off the east coast of Canada, off Newfoundland, and we're working with the Canadian government, helping them with an annual survey that they do, and they've been doing it since 1998. They take readings and samples of water from all around the coast of Newfoundland and Nova Scotia, just to see how things are changing. So they're looking at water samples, biology, plankton, chemistry of the ocean, stuff like that. So it's an ongoing project for them. So it's important that they don't miss any samples of it in the spring and in the autumn, which is the one that we're doing now.
And do you go up there twice a year to do this work, or is it different vessels that go and support this?
It's different vessels. So they would normally work with a Canadian vessels, but they don't have any available at the moment. So we're doing it this year, and it looks like Discovery will be doing the same trip again this time next year.
Fantastic. And so tell me how long this trip is going to last. How long are you away from home on this time?
So this time we're away for about 9 weeks, which is kind of around about normal. So we're usually on board for about 2 months and we're off for about 2 months.
Okay, so just looking at your photo there, it looks like it's pretty sunny. Tell us a bit about what the conditions are like at the moment.
Yeah, it is actually. It's very sunny. There's not many clouds in the sky, which is quite unusual for this time of year. We've had quite a lot of fog just because we're off Canada, off the area called the Grand Banks and Flemish Cap, which is quite notorious for being foggy. So we've had a lot of fog, but today it's sunny. The sea's quite nice and calm. We've got a little bit of a swell, but there's not much wind, so it's just it's fairly flat today.
Perfect. And tell me a bit about your ship. How many people do you have on board? What capability does it have?
So at the moment we've got 38 people on board. So that's made up of 22 crew and then 16 scientists and technicians. But we can carry up to 54 people in total. So again, that's usually around about 22 crew, and then the rest made up of scientists of the scientific party. Mainly the crew are there to run the ship, to operate the ship, operate the equipment. The technicians operate the scientific equipment, and then the scientists do the science, obviously.
Fantastic. And I gather that some of your work addresses climate change. I know this is definitely a topic of interest for many of us. So can you tell us a bit about how your work goes about addressing climate change?
Yeah, so a lot of the work the scientists do is geared towards that. We do take different groups of scientists out all the time, so every trip is different, a different group of scientists, but a lot of the work that they're doing is geared towards climate change. They're measuring how things are changing, acidification of the oceans, how much it's warming up. Sometimes they'll be taking air samples as well as the water samples, and they can see how yes, mainly how the sea is changing, how the biology in the sea is changing, how the chemistry in the sea is changing. So yeah, it's quite a big subject, obviously.
Fantastic. So I want to shift a little bit to talk a bit more about you as a captain. I'm interested to find out, like, how long have you been the captain for, and kind of what are your roles and responsibilities?
So I've been captain on the James Cook for 7 years now. And yeah, responsibilities. The main job of the captain really is to make sure the ship and the crew are safe at all times. Whether that's coming in and out of port, avoiding rough weather or heavy weather that can cause damage to the ship, making sure that the operations are going correctly, making sure that just everyone's doing the job that they're supposed to do, which is usually the case. And if everybody's doing that, then the ship is safe. But then we also obviously, the secondary is to make sure that the scientists are getting what the data and the information that they need. So to do that, they need the ship and everything and everybody on board to be working properly. So those are kind of the main jobs.
Okay, and how did you get into becoming a captain? Is it many years of work that enables you to reach this rank? What drew you to it?
It took me let me see, 12 years to get the master's qualification.
So what are the kind of highlights of your job? What are your career highlights so far?
So it's mostly, particularly with this job, it's always interesting working with the scientists. Yeah, so we've been to some interesting places. Particular highlights would be working down in the Southern Ocean around Antarctica. So last year we went to have a look at a big iceberg that had broken off from Antarctica and was threatening to ground off South Georgia. So that was quite interesting. So we had to try and get quite close up to this giant iceberg, which had lots of smaller bergs and bergy bits and growlers and things like that around it. So that was quite interesting.
That sounds fantastic. And I guess the other highlight must be that you get to see some really interesting wildlife being out at sea for so many months in so many different places. Can you talk a bit about the animals that keep you company on your expeditions?
Yeah, so majority of the creatures we see, obviously, are whales and dolphins, I suppose. They can be quite elusive, but on occasions they do come up very close to the ship. So again, a few years ago we were in the Southern Ocean. We were stopped in the water doing an ROV job, so the ship wasn't moving, and we had about 4 or 5 humpback whales who came up extremely close to the ship to have a look at us, and they were there all day. They were swimming around the ship, and you could almost reach out and touch them. They were so close.
Oh my goodness, that sounds magical. Great. Well, just to end, I just wonder if you have any advice that you would give to a younger you. So are you maybe in secondary school? What would you say to yourself if you could reach back in time?
That's quite a tricky one. I suppose I would say that I don't know, good or bad, any experience is experience. You can always use it one way or another.
Yeah, that sounds like good advice, sound advice. Captain James, thank you so much for joining me today. It's been a real pleasure speaking to you, and good luck with the rest of your expedition.
Thank you very much, virtual Susie.
Real Susie.
I'm enjoying all this careers advice. I'm taking it all on board because I still don't know what I want to do when I grow up. I don't know whether I'm going to go and become a polar scientist or go and captain a ship. It is never too late, I think. So thank you very much to James and... what was the name of our other captain?
Stuart.
Stuart. Thank you very much, James and Stuart, for giving us your time to do that. Hey, we're joined by a science legend, a yellow science legend behind us. None other than Boaty McBoatface. I don't know if the young people here watching this remember the whole Boaty McBoatface
We'll
debacle.
be talking about that. But actually, live with us here, we have Professor Angela Hatton, who is Director of Science and Technology at the National Oceanography Centre. And we have Matt Kingsland, who's a senior engineer here, to tell us a little bit more about Boaty McBoatface and its journeys.
So Boaty McBoatface, which is one of our autonomous long-range vehicles, is something we've designed here at the National Oceanography Centre. So if you've got a particular interest in engineering, we very much engineered this from the beginning. All the mechanicals, all the electronics we have developed in-house here, and it's a great job. as we were talking about careers.
Can I just ask you about
Yes.
the name? Because there was an internet sensation a few years ago when was it you guys who foolishly said to the world, what are we going to call our new ship that we're building?
So it was the new Sir David Attenborough. So
Yeah.
the new polar ice research vessel, big red ship, and they decided to go with the name Sir David Attenborough. But Boaty McBoatface, our submarines here, get launched off the Sir David Attenborough. And thus they decided to call the subs Boaty McBoatface, which
There was
After
a
the public vote.
there was a public vote. There was a public vote. So these vehicles are long-range vehicles, so they can do up to 4,000 kilometers. We recently had one in the Atlantic, which was deployed from Plymouth. So it drove itself out from Plymouth all the way to the continental shelf. It dived down to 1,000 meters and then drove itself all the way back. And this is really carbon-friendly ways to do science. We use very, very little fossil fuels doing that because she's battery-powered and she's rechargeable. And to put that in perspective of how far she pretty much went to the south of Spain and back from Plymouth in the UK. And I believe we've now got a video showing some of our work offshore on the Discovery ship that you saw the captain of moments ago. And this is us deploying this vehicle off the RRS, the Royal Research Ship Discovery. The particular submarine that you've got in front of you, which you can just see that they're putting the lid on to make really hydrodynamic, navigates in a very similar way to bats. So bats use echolocation and acoustics to work out where objects are and what to avoid, and so do our submarines. So they don't generally have cameras. The eyes of the submarine are acoustic devices. So it transmits an acoustic sound wave, and the reflections it gets off the seabed or other obstacles in front of the vehicle, such as icebergs or unknown obstacles, such as shipwrecks, it can then autonomously make the decision to avoid those obstacles that it's got. The science that it does while it's deployed is very important to a whole range of studies that are going on. So, for example, some of the data that this vehicle collects is used to aid in your weather forecasts. So we collect something called conductivity, which is how salty the water is, along with temperature data and at what depth we collect that data at. You can see in the image there that she is propelled by a single propeller, and some foils on the back there provide the plane, the movement, so she can direct herself in the correct direction. She knows where she's going based on a compass, so very much a classic form of navigation system. Underwater, GPS does not work, so navigating these vehicles underwater is very, very challenging when you imagine that we spend so much of our lives today relying on GPS, on your phone, on your sat-nav, and wherever you're going. So the vehicle that's in the picture, they're about to deploy, and it's off to do a survey of a marine environmental protected area, which is off the coast of the UK, just north of the Scilly Isles and just south of Ireland. And it's a place called Hague Frass, which is a site of scientific value. It's a representation of all the biodiverse life which is in the oceans off the UK coast, and we use it as a monitoring site to work out how we better treat our oceans. If something's going wrong at the Hague Frass site, we can then extrapolate the data and assume it may be happening in other locations around the coast. So we monitor this site quite closely, specifically for checking our seas and making sure they are healthy. The team is about to put her in the water. So in a moment you will see Boaty get launched, and after she's launched off the ship, she's an autonomous vehicle, so we tell her where to go and what to do, but then once she has dived, she's on her own, and she will carry on and make decisions for herself, whether that is to continue with the mission or whether something else is happening and she should do something else. So my colleague Ed in the video at the moment is mission planning for the vehicle, and they are deciding where in Hague-Fras to send the vehicle so it collects the best data and does the best science for the time that we are deployed. So yes, they're very exciting vehicles.
That's absolutely fantastic.
Absolutely. I've got a billion questions, which I'm not going to ask you because we've got some really interesting questions that have been sent in. So thanks very much to everybody who sent a question. Where do we even start with this? I think All Saints Academy, I think this is a kind of quite a general question, maybe for Angela. What would you say, thank you All Saints Academy, by the way, for this, is the biggest threat to our oceans?
Oh, so I actually think it's a combination. So they're all sort of linked. So if you think of climate change, so carbon's gone into the atmosphere, it's changing the chemistry of the ocean, it's changing the physics of the ocean, so it's heating, it's expanding the ocean, but it's also having an impact in terms of sea level rise. So if you take something like coral reefs, which I mentioned earlier, they're under threat from multiple layers based on that carbon we put in the atmosphere. So it's I would say that the carbon dioxide we're putting in the atmosphere is creating that multi-stressor that's affecting a lot of the biology in the ocean. And obviously then there's other pollution we create, such as plastics. But for me, the biggest thing is if we don't get on top of the climate situation, which will help with a lot of other situations, that's going to be the issue.
Yeah, so climate change, one of the biggest threats to the oceans, or the biggest threat to the ocean.
That's a really interesting point. Actually, Mrs. Booth at Sutton Academy, one of your students has asked, which kind of leads us on from what you were saying, Angela, are you developing any new technology to clean the ocean? We've been a lot of students have been asking questions about plastic pollution and such, and wondering, can Boaty McBoatface, can we attach a Hoover to it? Is there some kind of amazing new bit of kit that can help with that?
So I'll start if that's okay with that. So we do a number of things which is about thinking about mitigation of climate change. So we're thinking about how we solve the problems as well. So we do a lot of work on blue carbon, which is looking at environments in the coastal environment which absorbs a lot of carbon and make sure that they're being healthily restored to pull down carbon naturally. We work on areas like carbon capture and storage, which is how do we make sure that if there is carbon being generated, it's being stored in a way, and actually using, sometimes looking at whether you can use empty wells to put the carbon back in there and then keep it there for a very long time. And we do a lot of stuff to check that that's not leaking out and that we can actually do that. And these kind of instruments and a lot of the sensors we develop can go and monitor those things. So if people are going to go to the ocean to try to bring down carbon or to stop carbon coming out, the technology will allow us to see if that works.
I'm actually really interested in this technology for lots of reasons. One is that it's like the best self-driving car I've ever seen in my life. And second, we're thinking about going to other planets, having autonomous vehicles explore the oceans under these icy crusts of some of the outer planet giant moons. And the kind of technology that we're going to need is autonomous vehicles that go and do this kind of work.
Just borrow. We could put a Boaty McBoatface in space. That'd be awesome.
Nice. We have actually a question there. I should be asking their questions rather than mine, which is how deep have we explored and how deep will Boaty be able to go?
So Boaty can go to 6,000 meters, which is roughly 90, I believe it's 97% of the ocean is 6,000 meters or above.
Yep.
There's about 3% which is deeper than that, including things like you might have heard of, like the Marianas Trench, which goes all the way down to about 11,000 meters.
I think they found a Coke can down there or something terrible. There was
Plastic.
some kind of unbelievable
human waste.
Even down to those depths.
I've seen plastic bags, crisp packets at several thousand meters. So the recent plastic bag ban, where you've got to go and use reusable plastic bags, is genuinely a great idea, because I've seen disposable plastic bags in our oceans. And just to come back to your how do we clean up the oceans, the best solution is for it to not end up in the first place. The ocean is such a large place, and it's dark, it's cold, and exploring it is very, very difficult. taking the rubbish out of it is such a challenging demand. There are some people trying to do this in the Pacific, what's called the garbage patch, which is what's called a gyre. It's a giant swirling piece in the Pacific where all the rubbish accumulates, and they're trying to extract all of that at the moment. But it's such a challenging piece to do.
So lots of people have been asking us today, what can they do? We've got hundreds, thousands of people watching who all want to know, is there something that they could do to change things for the better? Do you have any thoughts, Angela, on that?
Yeah, so I think about this a lot. And for me, if you think that climate change has been generated by individual people making individual choices, and actually that means we can change the way we do that. We can make those choices as individuals that make a big difference. If we wait for other people to make the difference, then it might not happen as quick. So if every one of us thinks on every day about what you're doing, are you eating properly in terms of food being flown in from other countries, which seems like you don't need to do that? Are you thinking about having an electric car? Are you thinking about the fact that you can reduce your energy costs? That saves you money, but it also saves the planet. And at the moment, it's a doubly important thing. I mean, the energy costs are causing a huge amount of problems. So the decisions we make every day to make small steps with billions of people is what can make a big difference as well.
Great.
And of course, we hope policymakers will also do that too.
But I think policymakers and markets are determined by what they do, by what we do. So if we make positive changes, then governments and politicians and companies will change their behaviour.
Yeah, and you can talk with your family about what they could do. You can talk with your school and your STEM club about what your school could do to be more sustainable.
Talking of schools, I want to do a shout out. Thank you very much, Crestwood School and Lizos High School. I hope I've pronounced that right. And other schools have been asking lots about biology in the oceans as well. So I'm going to sort of put a few questions into one question. What exotic animals have you found? And another student was asking about megalodons.
Yes, are there megalodons in the
Isaac,
oceans?
year 9. Hi, Isaac. He wants to know about megalodons, of course. Are they still in our oceans? What has Boaty discovered?
So my understanding is there are no megalodons left in the ocean.
No!
However,
Isaac, I'm sorry.
However, I can tell you that on the Pacific, where we're sending one of the James Cook at the moment is on its way to the Pacific, and they have previously found megalodon teeth when exploring the Pacific.
Nice.
So they're hoping to find some more when they go out there.
And do the animals in the ocean interact with Boaty as it makes its journey? Do you find animals that are interested in it, or is it largely ignored?
So it's kind of counterintuitive. You would expect to put cameras forward on a submarine and see things in front of it.
Yeah.
That's not how they work. If you put the camera backwards, there are loads and loads of little fish following the submarine around. So we've actually learned that you put cameras facing backwards, and yes, we've had dolphins interact with the submarine, where it uses echolocation, so do dolphins. They have interacted previously as well, and we did check it was a happy dolphin.
Good.
Oh,
So
fantastic.
it wasn't an angry dolphin.
I was a little disappointed. Well, not disappointed, because I thought there was a single Boaty McBoatface.
Yes.
And yet there are several Boaty McBoatfaces in where we're...
Yes, so there isn't just one. We've currently got 6, and we're planning to make up to 24.
Wow.
Their long-term strategy for us as scientists is to reduce our carbon footprint as much as it is for everybody else to reduce their carbon footprint. And these submarines help us do that by us not needing as much ship time, which all ships burn a huge amount of fossil fuels, lots of diesel, circa 10 to 11 tons a day per ship for them to cross the ocean. And to send out these vehicles instead, it takes about 2 litres, or the equivalent carbon footprint of about 2 litres worth of fuel for this to do surveys versus the ship.
So we need more Boaties, that's the
We
answer.
need more Boaties.
More
Hey,
Boaties in the
Angela,
future.
Matt, thank you very much. You are both my heroes. And I just say that. For everyone we've been speaking to today as my heroes, I'm getting all these ideas about what I want to do when I grow up. I want to be a scientist, I want to be a Boaty driver, all kinds of things. Hey, we're coming to the end of our ocean session. Thank you very, very much to all the schools who have joined us and given us questions. We've just got to do a little sign-off and tell you about our...
Yes, if you are interested in the oceans, finding out more about the oceans, then of course you can do that by going to the STEM Learning website. You could go to the Explorify website if you're a primary school. The links will be in the Q&A here on Teams. And you can also go to some of our partners in the Climate Change Educational Partnership. For example, the Royal Geographical Society, Royal Meteorological Society, the Royal Society.
Lots of royals.
Lots of royals. Natural History Museum. There's loads and loads of links that you can find now if you want to explore more. And we'd really love all those educators out there to think about how climate change can be in the curriculum.
And also reach out, because you can get climate experts like Angela and Matt, maybe, to come and visit your school.
We're not promising them.
We're not promising. But reach out to experts, because I know for a fact that they love to come and visit schools and do talks. So, you know, reach out widely and get an expert to come to your school and help join your own initiatives.
Great. So we're going to wrap up this session now, but we'll be back with you in 5 minutes to be talking about forests. So please join us.